In this series of videos, we're going to talk about techniques in graphing, which include transformations. So transformations include translating left, right, up, down, also includes reflections, and sometimes vertical stretches and shrinks, and maybe even a horizontal stretch or shrink. But we're going to keep it simple in these videos. First of all, we've got a function, f of x. If we take that function and we add a value on the outside, that's going to shift that parent function up c units. If we subtract c from our parent function, it's going to shift that parent function down c units. Now, sometimes we add or subtract inside the function. So that's what we're seeing right here, is we're adding inside the function. When we add inside the function, we're going to move our parent function left. And when we subtract inside the function, we're going to translate our parent function right. And then we have our reflections in the x-axis and in the y-axis. If we take the opposite of our parent function, so this opposite on the outside of our parent function, I'll give you an example. If we have the parent function y equals, let's say, the absolute value of x, if we take a negative to the outside of that absolute value function, we're going to reflect over the x-axis. However, if we have a parent function, let's just say, we could say absolute value of x, but we put that negative on the inside, that's going to be a reflect in the y-axis. So that will flip over the y-axis. And here's what that negative looks like on the inside. Okay, let's describe the translation and sketch each of these functions. We have this y equals 1 over x minus 2 plus 3. At this point, you should be able to recognize the parent function. We went over several parent functions, and it's important to know those parent functions for what we're going to do here. So you should know them fairly quickly. You should be able to graph each one by looking and within 30 seconds or less. And I'll show you why. Here we have our parent function. I'm going to list that is y equals 1 over x. So I'm going to plot that parent function. So plot the parent function. We know we have these 3 points right here. And I'm just going to make a little dashed line. And then we have these 3 points right here. And again, I'm going to make a dashed line. Now this entire function right here, this entire parent function, I get to do this because I have this cool technology, is going to get shifted. We're going to be moving it left, right, up, down. See how cool that is? So we just have to decide what's the translation. So we've got this subtract 2 inside the function, and we've got an add 3 outside the function. I'm going to remove these highlights because I don't want you to think that I'm color coding with what I highlighted above. So the subtract 2 inside means right 2. And the add 3 outside is up 3. So that's because minus 2 was on the inside and plus 3 was on the outside of that parent function. So back to my technology over here, we're going to move this function right 2 units and then up 1, 2, 3. So it's going to look just like that. But I'm going to show you how we're going to do this. We know that this function has some asymptotes. So it has an asymptote that's vertical along the y-axis. That's going to adjust by moving right 2. And then we have the horizontal asymptote along the x-axis, and that is going to go up 3. So there's our new asymptotes. And then from those new asymptotes, we can plot those same points. 1, 2, 3, 1, 2, 3. And this blue curve is going to end up being our graph. And then with an eraser, we go and we take out the part that's not really the graph right there. It's not part of our graph. It's part of a parent function, but definitely not part of y equals 1 over x minus 2 plus 3. Okay, let's try another one. Y equals the absolute value of x plus 2 minus 4. This parent function is y equals the absolute value of x. It's an absolute value function. And you can see that inside the absolute value, its name is absolute value, so inside the absolute value, we have plus 2, and on the outside, we have minus 4. Well, this plus 2 means go left 2, and this minus 4 on the outside means that we're going to translate the function down 4 units. So we have an idea of what this is. This is a V, normally with a vertex at the origin, but that origin is going to move left 2 and down 4. Left 2 and down 4. We'll put our vertex right here. And then this is why it's so important to be able to graph those functions and know what they look like, because from the vertex we go up 1, left 1, up 1, left 1, up 1, left 1. And then from the vertex we go up 1, right 1, up 1, right 1, and we fill in the grid as completely as we can. We use a straight edge because these are straight lines, and we enter and exit the grid. And those are a couple of examples of some easy translations. So let's go to, I don't know if you have a try. You could probably, if you know your parent functions, you can try this next one. If you need some help, just press pause. But if you feel comfortable enough, it does have this little pesky negative on the outside, so I am going to explain it. So this parent function is y equals x cubed. It's a cubic function. And it's got a couple of things going on. It's got the reflect, it's got left 1, and then it's got up 2. So I'm going to write those things down. We always reflect first. So whenever we have that negative either on the inside or the outside, we're going to do that reflect. And that outside means a reflect over the x-axis. And then plus 1 is left 1. And plus 2 on the outside is up 2. So this one I'm going to show you a little bit differently. I'm going to plot just the points of the parent function. So in gray, I've got -2, -8, -1, -1, 0, 0, 1, 1, 2, 8. And now I'm going to do these series of moves, starting with the reflection. So we always reflect first. So always do this first. With the way I'm showing you, you always want to do your reflection first. So I'm going to start with the point -2, -8. Reflect over x brings it up here. And then we're going to take that point and we're going to go left 1, up 2. And that's going to be our new point for our graph. Okay, let's try that again. I'm going to take -1, -1, and I'm going to reflect over the x-axis. And then I'm going to take that point, that reflection, and we're going to go left 1, up 2. I do the same thing with 0, 0. I reflect it over the x-axis. It's on the x-axis, so it's not going to go anywhere, but I do have to shift it left 1, up 2. And then we have 1, 1, the point at 1, 1. We're going to reflect that over the x-axis and then go left 1, up 2. And then we have our point at 2, 8. We reflect it over the x-axis, and then left 1, up 2. And now we can connect our dots, and we get our graph. I'm going to keep the gray points there just so that you can see them. Okay, now you should be ready. If you did not do that one as a try and get it right, you should feel really good about doing this now that you've seen it. So go ahead and try that, and then come back just for the answer. Okay, welcome back. You should have a point at 1, 6, -2 or +2, -1, +3, -2, +4, -3, and then +5, -10. So your graph should look like that. And if it does, fantastic. Okay, this next one is a great example of a negative on the outside or on the inside of the function. Listen very carefully. So hopefully listen carefully. Okay. If you're listening, this is so important. I'm going to start this on the next video.